So you're gonna have to guess what take number this is on this particular video. I need to get comfortable with the idea that I'm just gonna look like an idiot on camera, but it is a very hard reality for my psyche to accept. And so anyway, I appreciate your patience as I crank out these videos. So today, let me talk to you about the cool thing that we get to discuss today, and hopefully it blows your mind a little bit. We get to talk about Einstein's special theory of relativity, which basically redefines our concepts of space and time. So traditionally, you probably are used to thinking of space and time as static concepts, and what Einstein's theory does is it changes those concepts from being basically the canvas that the events of the universe are written on to active participants in the drama. And the faster you go, the slower time elapses for you. The faster you go, the shorter distances become in the direction of your motion. And that's crazy. It's outright bonkers that we actually believe this, and that it's in fact actually true. So if we're successful by the end of this video, this is what's going to happen. You'll be convinced that these conclusions, which were made by Albert Einstein, are not just probable, they are in fact inevitable, if it is in fact true that the speed of light is the same for everyone. So where does that, first of all, that little principle come from, that the speed of light is the same for everyone? It comes from Maxwell's equations. So Maxwell's equations for electromagnetism describe how all of electricity and magnetism work. And if you put them together in a complicated way, you get the wave speed, and this wave speed dictates how fast disturbances propagate. For electromagnetic waves, which turned out to be 3 times 10 to the raised to the 8th meters per second. But the equations didn't say with respect to what. And in fact, if you look closely at the equations and the assumptions that go into that number, you realize that it has to be the same for everyone because electromagnetism is true for everyone. And so a light beam then must pass everyone at 3 times 10 raised to the 8th meters per second, regardless of what their speed is. And that is a really crazy, crazy idea. So to kind of show you, to put a fine point on how disturbed this is, if you take, let's say you're driving a race car and you're driving at 200 miles per hour, your friend is edging up behind at like 205 miles per hour, and they pass you because they're moving faster. I could ask you right now, how fast do you think that the car would appear to be passing you if you're going 200 miles an hour and they're going 205? And the answer to that question, of course, is 5 miles an hour. You just subtract the two numbers in your head. It'll look like it'll be the same thing as if you were at rest and you see them creeping forward at 5 miles per hour. That's because our concept of motion is relative. We don't have a sense of motion until we accelerate. So if the speed of light passes everyone at 3 times 10 raised to the 8 meters per second, our concept of this relative motion has to be thrown in the garbage can. In this scenario, there's a person, and a light beam rushes past that person, and they see this light beam rush off at 3 times 10 raised to the 8 meters per second, because that's what the speed that they would observe things at, that's what they're required to observe. If I had a second observer looking at that same light beam, that was trying to chase that light beam, say at 2/3 the speed of light, according to our previous concept of how relativity works, we would say, well, the light beam would pass them at 1/3 the speed of light. The actuality is just nuts. It's that the speed of light doesn't seem to be any different for this individual. It's 3 times 10 raised to the 8th meters per second, still regardless of that running individual's speed. And so, you can see that this almost leads to internal seeming logical contradictions, right? Because it would appear the light beam's going so fast to pass you, and then to pass a person who's also moving at the speed of light, it would seem to have to speed up in order to do that. That's actually not what's going on. There really is something more fundamental that's happening to these two individuals' experience of reality. And Einstein was willing to say that for the individual that's moving quicker, their clock is running slower. Time is elapsing more slowly for them, and so they're interpreting 1/3 of the speed of light to be the full speed of light.